Okay, thank you so much. Welcome to today's tutorial. I'm going to teach you of how to charge a capacitor. Charging a capacitor. So, a capacitor is a device that is used to store charges, of which the symbol for capacitor are just two parallel lines which are equal in size. So, this is the symbol of a capacitor. Now, in this case, I need to show you how to charge a capacitor by use of a diagram. Now, a diagram. Now, from the diagram set up on the board, we have the DC source, that is the battery, rated 3 volts, and the milliammeter. These are rheostats. These are voltmeter connected across to the capacitor. Now, this is a closed circuit diagram. Now, this is the capacitor. Let me say this is plate A of the capacitor and this is plate B. Now, from the negative terminal of the battery, we follow the wire. So it means that plate B is negatively charged. Plate B is going to be negatively charged. And at the same time, the positive terminal through the milliammeter, through the rheostat to the plate A. So this side, this plate of the capacitor is positively charged because it is connected to the positive charge, to the positive terminal of the battery. The negatively charged plate is connected to the negative charge of the battery. Now, this is what happens during the charging of a capacitor. Now, the charges are going to flow from the negative terminal of the battery, of which the charges are just the electron. They are going to flow to plate B. So they are going to follow the path, this path, and they are going to be flowing from the negative terminal to plate B. At the same rate, the charges which are on plate A, the negative charges, the electrons, are flowing from plate A to the positive terminal. Now, the negative charges are being attracted to the positive terminal. That's why they are flowing from the plate A to the positive terminal. So during the charging of a capacitor, it is usually observed that the milliammeter reading decreases while the voltmeter reading increases. So this voltmeter has been connected across the capacitor. So it increases because the capacitor is being charged. Charges are flowing to the capacitor. So the negative charges are flowing to the plate B. At the same rate, the negative charges are flowing from the plate A to the positive terminal of the battery. So if negative charges flow from plate A, means that we are going to have more number of positive charges remaining at plate A. So if negative charges are flowing from the negative terminal of the battery, it implies that more number of negative charges are going to be on the plate B than the positive charges. So when the capacitor is fully charged, it is found that equal positive and negative charges are found on plate A and plate B respectively. So at the same time, when the capacitor is fully charged, the current does not flow, and this means that milliammeter does not deflect, means that the current has stopped to flow because the capacitor is fully charged. Now, when you have a graph of the current, which is measured in milliamperes against time. Now, this graph means that we're going to have such kind of a graph. It means that time is measured in seconds. The current is decreasing with time. Now, when you have a graph of the voltmeter reading against time, so the current is reducing exponentially. At the same time, when you have voltmeter reading, which is measured, voltmeter V, voltmeter reading, that is the potential difference in volts against time. Now, the voltmeter is connected across the capacitor. So the potential difference increases time in seconds. It increases exponentially until a point whereby the capacitor is fully charged. So the graph of potential difference against time is just the same as the graph of the charge on the capacitor, because the charge is increasing from 0 to maximum. Charge on the capacitor, charge Q in coulombs against the time. So also the charge is increasing. It is only the current which is decreasing, because the current is coming from the source. The voltmeter is connected across the capacitor, of which should be increasing because the capacitor is being charged, and also the charge on the capacitor is increasing. So thank you, and subscribe for more updates and for more videos.